Let W1 with a real vector space of 5 by 2 matrices such that the sum of entries in each row is 0, and W2 with a real vector space of 5 by 2 matrices such that entries in each column is 0, then dimension of the space W1 intersection W2 is. It means we have to find dimension of intersection as W1 is vector space of 5 by 2 matrices, and W2 is also a vector space of 5 by 2 matrices and having the property W1 row sum 0, row sum 0, and this W2 having the property column sum 0. Now we have to find dimension of intersection of W1 and W2. And what is the meaning of dimension? Dimension is number of non-zero elements. Number of non-zero elements in bases. In bases or bases. So there is no importance of saying non-zero elements, because if zero element is there, then set become dependent. So number of elements in bases normally called dimension, and bases elements are linearly independent at spanning, and they form a spanning set. So one method is find the dimension of W1 and W2, their sum, and apply this formula. Dimension of W1 here, because if normally A, B, C, D, this is the format of 2 by 2 matrices, then its basis B make first entry 1 and other 0. Again, B, in place of B, make 1 there and other entry 0. What it means? 1 0, it is first element. In place of B, make 1 and other entry 0. In place of C, make 1 and other entry 0. And in place D, make 1 and other entry 0. Then this is the elements in basis. So if matrix is given, it means non-zero or fields elements, number of fields elements considered as the dimension of the space. So dimension of W1 will be, because W1 size of W1 is 5 by 2, so maximum possible non-zero entries are 10, so its dimension is 10. Similarly, dimension of W2 will be 10, and find dimension of their sum W1 plus W2 and apply the formula W1 dimension of W1 plus dimension of W2 minus dimension of intersection of W1 and W2. So you can find dimension by using this formula. Or second method is find the basis of W1 for W2 also, and find common elements in their basis. That will give you the dimension of the intersection. So second method is this, but I am going to use other method. Sometimes it is very convenient when system of equation or linearly independent choices or constraint is given to us, then this method is useful. Also when matrices is given, then it is also when differential equation, solution of a differential equation is given, because solution of differential equation forms vector space. So this formula concept is more general and easy one, as W1 or W2 having the matrix size 5 by 2. So normally it will look like A, B, C, D, E, F, G, H, I, J. This is the format of the elements either in W2 or in W1. Consider a 3 by 3 matrix A, B, C, D, E, F, G, H, I. And I say row sum is 0. Row sum is 0. It means A plus B plus A for particular first row is equal to 0. It means all constituent sum is 0 in first row. It means you are independent. Either choose A or C. This is first pair. Then B will be additive inverse of their sum. If you choose AB, then C will be the additive inverse of their sum. If you choose is BC, then sum of there will be additive inverse of third entry. So suppose A equal to 1, B equal to 2, then C equal to minus of A plus B. It means minus 3. It means you are independent, only choose two entries here, then other will be dependable or depend. Similarly, for either in W1 or W2. So suppose this is the condition for W1 as row sum is 0, each row sum is 0. It means if A is non-zero entry, then B will be minus of A. So I change pen color so you can look better. If C here, then it will be minus E. If E, then it will be minus E, minus G, and minus I. By this is the property of W1, and by the property of W2, column sum is 0. Then suppose for convenience these four entries are non-zero or independent choice, then this last entry will depends on their sum. It means this I entry will be A plus C plus E plus Z, and it's negative. And this one, what is their sum for second column? For second column sum will be minus A minus C minus E minus G. So this is minus I. So minus I will be A, C, E, G, and their sum will be 0. So it is perfect. So how many independent choice or non-zero values here? Maximum non-zero value A, C, E, G. I is dependent on their sum. So 4 independent choice here. So dimension of W1 intersection W2 is 4.